So now I'm pleased to introduce our next speaker, Jin Kim from Samsung's memory business. I mentioned this morning, of course, everyone knows computer vision, deep learning require massive amounts of data. That means massive amounts of memory. And often what in BDTI's work in software optimization these days, we often find that although the focus is on processing performance, it's often moving things in and out of memory is actually the more difficult challenge, getting that to work efficiently. And so I think it's great and appropriate that Samsung is thinking about how to ease those bottlenecks and also recognizing that this is going to be a collaborative undertaking because the data moves from the processor to memory and back. Those things need to be coordinated if we're going to make big strides. So welcome, Jin. Very glad to have you here.
Thank you, Chairman, for introduction. Good afternoon, everyone. My name is Jin Kim from Samsung Electronics. I'm much honored to be presenting at this great Alliance meeting. As everybody mentioned earlier, the Vision IoT industry continues to make remarkable progress, and innovative production are being announced. Traditionally, in the embedded system, the memory is all about the embedded memory, such as the SRAM, register, or the small storage. Today, the new vision application require the high performance and the computing power, such as the AR, VR, and the AI and automotive. But it is impossible to satisfy customers with the past IoT device, even smartphone. To solve this kind of the problem, Latch-Up system has increased the using off-chip memory, and how to use differentiated DRAM has been very important issues. So I'm going to talk about the meaning and the role of memory in the embedded application, vision application in the future. So the first I will refer to the convergence era by the smartphone in the past and the divergence era by various IoT devices in the future. And second, these various applications are becoming more and more memory sensitive. And we will talk about the memory requirement and the performance in the automotive and VR and mobile applications. And then we are going to propose various memory solutions to solve a lot of the barriers we are facing in these days. Today, we are doing a lot of things with our smartphone. On a smartphone, we listen to the music, watch a movie, read books, and even act as a friend and the assistant. But do you know this great smartphone is stopped the growing? We don't need to buy a new smartphone because of the smartphone cannot meet the mobile user experience. Today, the mobile user experience is expected to satisfy with the various Vision IoT devices. Already, VR, automotive, drone, and surveillance can deliver the satisfaction that smartphone users do not feel. It is just the beginning of a divergence from convergence era with the Vision IoT devices. So, is smartphone meaningless in the divergence era? The answer is no. Smartphone is changing the role with various Vision IoT devices. It is an intelligent hub for data generation and distribution in the whole cloud ecosystems. And through the various IoT device, we can get the various information, and we can make the customized representation based on the big data. And another trend to notice is that the artificial intelligence service using big data and deep learning In these days, this kind of service are very costly and time consuming. And cloud service compensate, such as the cloud service companies, such as Google, Facebook, Amazon, are going to personalize the smartphone as a big data hub. This kind of various recommended data are represented on a lot of the IoT devices. This whole cycle on the ecosystem enrich the entire mobile echo and help us make IoT device more useful. In order to popular innovative the technology, it is very important to build ecosystems. In the past, we have to remember 3D TV cases, which was not enough for the 3D content. Next, we will talk about the artificial intelligence, which is one of the most memory-intensive trend in the Vision IoT. This picture is a concept of the application ranges in the artificial intelligence service. The x-axis is represent the prediction, the accuracy, and the y-axis represent the application, the coverage. The currently AI service is supported by cloud data analysis and deep learning. For example, the natural language translation, assistance, and recommendations. Today, including smartphone, IoT applications are extremely hardware limited. However, on-device AI demand is continuously increasing because of privacy and the security and the response time. We don't want to load our private data in the cloud, and there is always a risk of hacking. In principle, this method is neither fast feedback nor the energy efficient. In these days, this demand is still limited by device performance itself, but it is steadily increasing. And most mobile app vendors already are preparing it using GPU and DSP or dedicated hardware resource. In result, this kind of on-device AI service can achieve the energy efficient and high bandwidth usage and low latency compared to cloud services. Actually, you are more the professional than me about this kind of the technology trend. But the reason why I came up with this story is that this trend has a huge impact on the memory industry. So let's go to the main thread and start the memory story. And we will talk about the memory requirement and the performance trend in some application of the Vision IoT. And I will mention what is the limit of IoT memory subsystems. Today, the various IoT devices reach 50 billion units. So I have compared the memory impact for the top 10 IoT applications. The first, the core technology of Vision IoT is developing from imaging to recognition and artificial intelligence, which is closely related to memory performance. And at this time, we can define that imaging is improving picture quality and high-speed shooting and continuous shooting. And the recognition is 3D mapping, multi-camera and object motion and face recognition and biometrics. And AI is autonomous and emotion recognition and disease diagnosis. So in the left table, you can see that the automotive is most closely related to the memory, the performance. After that, the vision IoT follows, like as the robot and the drone. In the past, traditional the imaging, the improvement is relatively less memory intensive. But in the future, it is that the complex the AI, the application required more memory the performance. And it may determine the system performance. Okay, let's look at the automotive, which is the most memory intensive applications. In the left graph, the interesting point is that in terms of performance, automotive has already overtaken the smartphone industry. Although it's not the autonomous vehicle era yet, memory performance is exponentially increasing in this year, and the driving force behind this trend is the computing ADAS. Even if the autonomous vehicle is not available, it will gradually adopt the vision ADAS the system, which is require the most high memory performance in the near future. In the right picture, in 2017, on the 50 gigabyte per second bandwidth is required, but in 2021, over 200 gigabyte per second memory bandwidth is required for only the computing ADAS. The memory bandwidth is about 8 times increase than this year. And this level of the memory performance can achieve over 1,000 object recognition as well. These kinds of high bandwidth memories are mainly used for object detection and scene segmentation and depth extraction in the ADAS system. Another IoT device is the VR. The remarkable interest in the last year has been somewhat reduced, but its role as major vision IoT is very, very notable. And memory demand continuously will be increased. VR is the drop-in type using the smartphone, existing smartphone, and tethered type using the desktop. And another type is the all-in-one that compensated for the drawback of the drop-in and the tethered. The tethered type is target the existing VR game and require 16 gigabyte the capacity of GDDR5 and 1 terabyte per bandwidth is the high-end graphic card. However, there is a serious problem to have to solve. It is the thermal and the power issues. On the other hand, the drop-in type is limited in only the watching streaming movies because of hardware limit. However, VR user want to both mobile user experience and VR gaming performance. Maybe the memory is expected to require 8 gigabyte capacity and 50 gigabyte per second bandwidth in all-in-one device. The right side shows the trend of display and latency in the VR technology. It is currently about 4K resolution and 75 frames per second, but by 2020, it is expected to grow to 8K resolution and 9 millisecond MTP. The MTP is the motion to photon. At this time, memory performance is essential. And the other hand, what about the smartphone in these days? In the left picture, while the performance of SoC is advancing competitively, but entire system power is still a big problem. The power of memory itself is steadily declining, but unfortunately, the memory budget of the whole mobile system power is not large. However, the portion has been continuously increasing due to the VR user experience and the high-end gaming attach ratio in mobile. In the middle, overall, the performance increase is necessary, but it is trapped in the limit of power budget, and they have to solve the summer issues. In the right picture, if this kind of headache could be solved, the memory bandwidth will be able to continuously increase in mobile system. Anyway, in conclusion, interface power reduction is very, very important. And collaboration with the SoC and memory is more important than power reduction of the device itself. This slide shows the innovative the extension of the memory performance and the power efficiency. The left picture is the performance trend in time. Now we already support around 10 gigabps GDDR5 and 4 gigabps LP4X and 3 gigabps DDR4. And in 28, we will be able to support approximately the 14 gigabps GDDR6 and 6 gigabps LP5 and 4 gigabps DDR5. In terms of the performance, I'm very happy you can understand we make a lot of the technical effort for this extension. The right picture is the power efficiency trend in time. If we guess the power of the DDR3 is 100%, we reduce the 50% in GDDR5 and 40% in LP4X and 60% DDR4 compared to DDR3. In 2018, we are going to reduce to more around 20% of the current DRAM power. I'm sure that in Vision IoT industry, the high-speed GDDR5 and 6 and power efficiency LP4X and LP5 is the most attractive of the solutions. As you have seen, the power of the memory itself decreased continuously, but the whole system power is getting slower. So it cannot satisfy various application requirements of the future. So in order to this problem, we have to consider various innovative solutions in the memory side. The first approach is HBM, high bandwidth memory. We saw the possibility of innovative memory solution through the HBM. The HBM performance of 1 terabyte per second exceeds 50 gigabyte per second, which is the limit of traditional graphic memory, GDDR5. And the HBM is the memory stacked SiP package solution, which is the connected the logic processor through the silicon interposer. The currently 8-tight stacked 20 nanometer and 8 gigabyte, and we will continuously scale down. And already discussing next HBM spec, HBM 3. The HBM is adopted new memory technology, which has the maximum 8-tight stacked structure and micro bump and the silicon interposer and around 1,000 TSVs. The HBM is 8 gigabyte per package capacity. The performance is 2.7 times than GDDR5, and the power efficiency is 0.8 times than the GDDR5. We already have a mass production line in terms of the memory stacking, and the test coverage and the reliability. And it seems to be continuously cost down over time. We are now thinking about spreading and applying to other areas, such as mobile and vision IoT devices. The next, I will talk about the IoT and the mobile memory package trend. The left picture shows the package trend in the server and the graphic applications. As I mentioned, TSV-based stacking and the silicon interposer technology has already been used with the HBM. And we already supported the mass production for high-end graphic card and the cloud server system. In the right picture, mobile is still a wired and bumped solution, packaged at the technology level, but 2.5D or the 3D SiP structure will be applied in the future using TSV and the silicon interposer. In result, this kind of packaging can naturally achieve low power and small form factor and high bandwidth. In addition, as you can see the picture, SoC and the memory is not a different device. And you can use high capacity DRAM in one same packaging, just like embedded SRAM in the past. So let's see the future memory, the solution for the actual application. Previous page, I have noted that the AI is the future, the trend, and the on-device AI is going to value shift. The left picture shows the dedicated hardware is more energy efficient. And it has a better performance than general proposal of CPU or the mobile AP is in the future applications. The combination of the accelerator and the HBM, which is already optimized for parallel processing in server and hardware graphic. It has already the excellent performance. However, in the entire AI systems, the value is gradually shifting to on-device because of privacy and latency and power. In the right picture, after receiving only the trained model in the cloud, the vision IoT satisfied in the real time the mobile user experience and deliver the private data safely through the inference processing on device. The mobile and the vision IoT is faced with the right time, when energy efficient and the high dedicated hardware is required, which is the combination of accelerator and the memory in the AI IoT system. And in the CIS field, it is required the performance of the DSLR the level, which are very high quality photography, high speed shooting, and buffer memory solution is required by difference of SoC and the CIS speed window. In this trend, we can think just such a stacked memory is the basis of the IoT, the innovation. And you can catch the concept of processing in memory, such as the high-speed readout and the data rate control and the multi-stream model. In addition, if we could collaborate with each other, like as the embedded SRAM, we could easily achieve a lot of things, such as low power, thermal spread, super resolution, real-time HDR, and slow motion control. This is another advanced approach to have lower power consumption. The recently all-in-one VR and the smartphone requires simultaneously PC level the graphic and the mobile power budget. In this case, each chip or the function needed to use common DRAM through the common memory bus. In order to cover this operation, extreme memory bandwidth is required. But unfortunately, with a limited power budget, even full bandwidth cannot be used. To reduce the unnecessary data movement and the frame rate control, we cannot added more value for accelerator and SoC. For example, the pre-processing and the post-processing with the camera and the VR display. Regarding pre-processing, there are image and gesture recognition using deep learning algorithm. Regarding post-processing in VR, we can consider time warp and range distortion and chromatic aberration correction and the frame rate control. However, these approaches require the closer collaboration between the SoC and the memory. And we'd like to propose a collaboration in terms of vision processing in memory. Okay, this is summarized. As I mentioned on previous slide, future vision IoT require the extreme memory band performance at ultra low power. The first, smartphone as the intelligent hub will continue to enrich the mobile ecosystem. We have to watch it carefully, the mobile challenges, with power optimization and innovation approach. The second, the high performance and more memory are required in the vision IoT. The first is automotive ADAS that drives the high bandwidth memory. And immersive VR requires simultaneously high performance and low power. And the mobile memory is getting more power efficient and will be the challenge. In order to overcome lots of the barriers, this kind of mobile challenges, SoC and the DRAM itself cannot solve this kind of issues. So we have to collaborate with each closely to find out the right memory solution. The beginning point is the artificial intelligent memory and CIS stacked memory and the vision processing in memory. Thank you for your attention.